Now I will start with introduction of the research. Our study is about developing NUTRISEA CENDOL. For the first problem statement, although this seaweed is rich in mineral and carrageenan that can improve texture and moisture retention, its high mineral content may also affect the taste, texture, and safety of the product. However, study on how it fluence ash, synersis, moisture, and texture analysis in CENDOL are still limited. Secondly, the rheological properties such as flow behavior, viscosity, and stability are not well understood. While carrageenan is known to enhance gel strength and elasticity, the specific role of carrageenan from this seaweed in CENDOL jelly remains unclear. Lastly, there is limited research on consumer acceptance. Even though seaweed can improve chewiness and moisture retention, how these changes affect the flavor, texture, and overall acceptance of CENDOL jelly is still uncertain. The first objective is to determine the physicochemical properties of NUTRISEA CENDOL, focusing on hardness, cohesiness, springiness, and adhesiveness. The second objective is to determine the effect of rheological changes on the NUTRISEA CENDOL. This means we want to see how the flow and structure of the product change the different formulations. And lastly, to evaluate customer acceptance of NUTRISEA CENDOL through sensory evaluation.
This research framework shows the overall methodology for developed NUTRISEA CENDOL enriched with KAPPAPHYCUS ALVAREZII. So 3 formulations were prepared, which is formulation 1, 2, and 3, contain 3%, 4%, and 6% of seaweed. In each formulation, rice flour was substituted with KAPPAPHYCUS ALVAREZII.
This flowchart shows the procedure texture profile analysis. This flowchart shows the procedure for moisture content analysis. This flowchart shows the procedure for total ash analysis. This flowchart shows the procedure for synersis analysis. This flowchart shows the procedure for rheology analysis. This flowchart shows the procedure for sensory evaluation.
So here, I will be explaining the texture profile analysis result. From the table and graph, we can see 4 parameter measure, which is hardness, cohesiness, springiness, and adhesiveness for the control and 3 different formulations. First, let's look at hardness. We can see that formulation 3 recorded the highest hardness value while the control was lowest. This means formulation 3 is the firmest among all samples, which show the formulation changes increase the texture strength. Next, for the cohesiness, the value ranged from 1.36 to 1.89 and the difference were not significant. Moving on springiness, the result varied between 4.60 and 5.03, but again, the difference were not significant. And lastly, for adhesiveness, formulation 1 was the least sticky, while the control was the stickiest.
I will present about result in discussion for moisture content analysis. This is bar graph, which is show the moisture content range for all sample is 4.10% to 4.37%. Formulation 3 show the high moisture content, while the control show the lowest moisture content.
For the total ash analysis, the control sample had the lowest ash value, around 0.43%, because it's only used flour and pandan juice, which have very little minerals. When KAPPAPHYCUS ALVAREZII was added in formulation 1, the ash content increased slightly. In formulation 2 and 3, the ash value increased more as the amount of seaweed become higher. This shows that the more seaweed added, the more minerals are present in the samples.
In result and discussion, I will present synersis analysis and rheology analysis. In this analysis, synersis was measured for 10 days to observe change during storage. On day 1, the value ranged from 14.43 to 15.5 per gram, with formulation 2 showing the highest synersis. This means the gel network was weaker and less able to hold water due to a less compact structure and weaker hydrogen bonding. All formulations show a decrease in synersis as storage continues, mean the gel become more stable over time. Synersis value dropped by day 10 to 12.27 to 13.84 gram. This is because the gel structure stabilized during refrigeration, as supported by Yusuf 2023. Among all samples, formulation 3 had the lowest synersis on day 10. the best water holding capacity due to the KAPPAPHYCUS content, which contain carrageenan. This makes a strong gelling agent that prevents water separation. So, formulation 3 was the most stable as reduced synersis helped maintain texture, appearance, and mouthfeel throughout storage. From this graph, we can observe the storage modulus or G', which indicate the gel elastic behavior during heating. As temperature increased, G' decreased due to weakening of the gel structure. The control sample show the lowest G' value around 75676 Pascal, while the formulation with seaweed shows significantly highest value. This indicates that incorporating KAPPAPHYCUS alvarezii increased the gel strength of CENDOL. From the result, formulation 1 with 3% seaweed reached 110.415 Pascal. Formulation 2 with 4% of seaweed increased further to 160.210 Pascal, and formulation 2 with 6% of seaweed showed the highest elasticity at 310.600 Pascal. This trend showed that higher seaweed concentration enhanced the gel network due to additional hydrocolloid content. In terms of glass transition temperature of TG, the control had the highest value at 46 Celsius, while the formulation with seaweed showed slightly lower TG value, decreasing to 38 Celsius in formulation 3. This showed that the addition of seaweed lowered the temperature at which the gel transitioned from solid-like to more fluid-like behavior, possibly due to increased moisture binding and flexibility of the polymer network. Overall, the result indicate that KAPPAPHYCUS alvarezii improved the structural stability and elasticity of the CENDOL gel.
This is the spider web graph, and the table show the result. And this table show the mean result for sensory evaluation. Out of 14 panelists who conducted sensory evaluation, the results show that formulation 3 reached the high score among formulation 1, 2, and control.
This is impact of our project analysis. The incorporation of KAPPAPHYCUS had a significant positive impact on the NUTRISEA CENDOL formulation. It enhanced the gel strength, texture, and overall stability of the CENDOL, resulting in a firmer and more stable gel structure. The addition of seaweed also reduced synersis, meaning less water was released during storage, which improved the water holding capacity and maintained a smoother texture. This improvement contributed to better shelf stability and overall product quality, making the CENDOL more suitable as a ready-to-eat dessert. Overall, this shows that KAPPAPHYCUS can function effectively as a natural hydrocolloid substitute, improving both the functionality and sensory quality of the traditional CENDOL.
Fourth sustainability of our product is environmental sustainability. Here, there are 3 environmental sustainability. The first is local and sustainable sources, which is the raw material we use are obtained from local supplier. The second one is use of natural and organic material, which is replacing such as artificial dyes with environmental friendly materials. And the lastly is selection of renewable resources, which is using marine plant material, namely KAPPAPHYCUS alvarezii. And the lastly is conclusion. In conclusion, our product, which is ready-to-eat NUTRISEA CENDOL, has been successfully processed using KAPPAPHYCUS alvarezii. Among the 3 formulations we test, including the control, we have proved that formulation 3 is the best formulation.